if, well, okay, we're trying to prove that AX plus BY plus C equals 0, a set of points for which AX plus BY plus C equals 0 constitutes a subspace of R2. So, first place, we recognize this as the equation of a line. I hope we've had a pre-calculus course that shows us that, and I hope we've had other courses where we've used the idea, okay? But in any case, it is a line. We could solve for y and get this into y equals mx plus b form. Okay, now if x1, y1 is on the line, then we got to prove that ax1, well then, if it's on this line, then ax1 plus by1 plus c equals 0, okay? Then we're going to look at scalar multiplication, okay? A scalar multiple of the point x1, y1, well, we have to have something to multiply by it. We can't use just any number, although we actually pretty much could use just about any number except 1 or 0 and get a counterexample. Okay, well anyhow, I'm going to still use gamma, third letter of the Greek alphabet, alpha, beta, gamma, instead of C, because we've already used C. Okay, so gamma times x1, y1 is just gamma x1, gamma y1. Now question, that's on the, okay, if this is on the line, then gamma yeah, that's right. Okay. A times gamma x1, which I wrote as gamma ax1, and b times gamma y1, which is gamma by1, plus c equals 0, right? Plugging in gamma x1 for the x-coordinate, gamma y1 for the y-coordinate, this would have to be the case. In this case, c equals negative gamma times ax1 plus by1. You know, just move over this on the other side. And you've got C, and of course I factored out the gamma. But what we know is that this point is on the line, so that C has to equal negative ax1 minus by1, okay? Now, can C equal this and this? Remember, C is a number in this equation. That number doesn't get to change, okay? So C is a number in the equation that defines the line. C can't have two different values, but unless gamma equals 1, this is different than this, which means that both of these can't be true, which means that if this is true, which it is since we've assumed x1, y1 is on the line, this can't be true, so that this point is not on the line, so that we don't have closure under scalar multiplication. That is, unless C happens to be 0, okay? Because if C is 0, that means ax1 plus b, well, ax plus by would have to be 0, so that your ax1 plus by1 would be 0, and so would negative gamma times ax1 plus by1. So, provided C isn't 0. So if C is not 0, ax plus by plus c equals 0 does not define a subspace of R2. Now, if C equals 0, the question is, do we have a subspace? Okay? And if so, then we will have proven that ax plus by plus c equals 0 is a subspace if and only if C equals 0. Okay? This proves that if C equals 0, we have a subspace, right? This proves that if C isn't 0, we don't have a subspace. So in order to have a subspace, C has to be 0. So it proves that only if C equals 0 do we have a subspace. So we proved that if C is 0, we have a subspace, and this proves that only if C equals 0 do we have a subspace. Meaning we can't have a subspace if C isn't 0. And that's what we proved. Okay.